let's take a look at another example to use a table to solve a probability problem with um, conditional probabilities and dependent events. So our problem says that according to the National Center for Health and Statistics, there's a 20.3% probability that a randomly selected resident of the United States, age 18 years or older, is a smoker. In addition, there's a 44.5% probability that a randomly selected resident of the U.S. aged 18 or older is female, given that he or she smokes. So that one we know is a conditional probability. What is the probability that a randomly selected resident of the U.S. aged 18 years or older is female and smokes? So we know that when we're done, this is the box that's going to be the numerator in our answer, because that's the box for the number of individuals that are both female and smoke. We're going to start just like we did with the last one. We're going to give ourselves some total number of individuals, and just based on the probabilities that I have, I'm going to start with 10,000. We'll see how that goes. So let's see what we can fill in here. First sentence, 20.3% probability that a randomly selected resident of the United States is a smoker. So that is going to help us fill in this box here, which is our total number of smokers. And we know that is going to be 20.3% of our total number of individuals, 10,000. So in that box we have 20,030 individuals. We may not need it, but just to take a look, we could fill in this box now by taking our total number of individuals, 10,000, subtract the number of smokers, and that would give us 7,970 for the number of non-smokers out of this kind of made-up set of 10,000 individuals. Okay, let's see what else we can fill in here. We have got the 44.5% probability that a randomly selected resident of the U.S. is female, but given that he or she smokes. So this now is females, but only out of the total population that smokes. So this is going to be 44.5% out of 2030, because that is the number of individuals we have in the smoking population. So when we multiply there, 0.445 times 2030, what we get is 903.35. So we're going to round that off to 904. Now, at this point in time, we don't need to fill in any more boxes because that was exactly the one that we needed. Certainly, if we needed this box here, we could take the total number of smokers, 2030, minus the number of females, 904, and that would give us 1126 for the number of smokers who are male. And actually from there, we would not be able to fill in either of these non-smoking boxes or total number of male and female, because we're just not given any information there. But we have everything we need now to answer this question. What is the probability that a randomly selected resident of the United States aged 18 years or older is female and smokes? So this is not a conditional probability. It's coming out of all 10,000 individuals, And the number that fall into the category we want, the female and the smoking category, is 904. So dividing there, we get a probability of 0.0904. Follow-up question to this, would it be unusual to randomly select a resident of the United States age 18 years or older who is female and smokes? So remember that the probability of this event is 0.0904. If we think of that in its fractional form, tenths, 9 is in the hundredths place. So it's about 9 out of every 100. Um, we're given the general guideline of 0.05 as a probability that makes something unusual. But remember, we also want to think about probability centered in, the specific event that you're talking about. If we're talking about here a probability of 0.09 that, excuse me, um, that it's going to rain when you're planning a picnic, you're probably going to go ahead with your picnic anyway. Sure, it does mean that if you plan a picnic 100 times under these circumstances, 9 of those times it's going to rain. But it isn't that disastrous. You'll probably have some fun with your friends anyway. On the other hand, let's say that you do not want to have a baby, but you engage in an activity that could result in a baby. And the birth control method that you use is going to fail with a probability of 0.09. So in that case, 9 out of every 100 times there's going to be a baby, which is a lot of babies. So I think everybody would agree that 0.09 would not make that baby very unusual in that case. So, everything is relative. Probability 0.09 that it rains on your picnic, meh, not a big deal. Probability 0.09 that something disastrous happens when you don't want it to, that is a very big deal indeed.